just a heads up.
All right. Good morning. I show it is 10:45 a.m., so we'll go ahead and call the meeting of the Texas Radiation Advisory Board to order. Just a reminder for everybody who's in attendance to make sure you're using your microphones and speak closely and clearly into those microphones so that it catches your audio. First item, roll call of TRAB members present. So we'll start over here with Dr. Metter.
Darlene Metter, TRAB member from San Antonio.
Mark Harvey, Texas Southern University.
Mike Brett, Insurance Industry.
Simon Trubeck, Austin Radiological Association.
Bob Redwick, representing oil and gas.
Kevin Robbie, representing the uranium in his industry.
Tim Val, representing low-level waste.
Sanjay Narayan, public member.
Roland Banky, Renaissance Code Development.
John Hagman, Certified Health Physicist and Consultant.
And then Will Pate, representing hospital administration. So we do have a quorum. Review and as needed discuss and take possible action concerning amendment and approval of November 3rd, 2023 TRAB board meeting minutes, which were sent out. Entertain a motion to approve those minutes.
I'll make a motion.
All right. I think we have a motion. Do we have a second? All right. We've any comments, discussion, correction on those minutes? All right. All in favor of approval of minutes, say aye.
Aye.
Aye. Any opposed or abstaining? All right. We'll consider the minutes to be approved. Public comment. We did not have anybody submit public comments online. Do we have anybody here in person for public comments? Nope. All right. Then we'll move on to the TRAB committee reports and recommendations. First up, Industrial, Nuclear Power, Uranium, and Waste Committee.
Darcy tried to open the meeting, but then had to step out and transferred it over to me. We did have a quorum. Ashley Forbes, status, the uranium sites and decommissioning with basically no change since the last meeting. During public comment, David Carlson identified that the NRC is currently drafting a revision to 10 CFR 61, which are the regulations for the classification of waste. Once published in the Federal Register, it's recommended that the revision be reviewed by INUW and the TRAB. Also, Commissioner Janeka informed the INUW of a working group promulgated by the governor to review advanced nuclear reactors and how Texas could become a leader in that area. And it's recommended that a TRAB get someone from the working group to come present to the TRAB their purpose and scope and offer how the TRAB could be of assistance. That ends my report.
All right. Thank you. Any questions? All right. Medical Committee.
So the medical committee met and had a quorum. We did elect our vice chair, which is going to be Dr. Lisa Masters. There was discussion on some continuing issues, updates on the ACMUI activities and committees, updates on remote CT operators, and the question of AU issues after an individual has relinquished their AU status and wants to then reestablish their AU authorization for that, for the procedures they are using in medical practice. And then we had some new topics regarding a new check cap device, which is FDA approved, but the NRC did not approve, and so I believe they've withdrawn their application. And then interesting, the status of an in-office dermatology radiotherapy. And we have nothing, though, to put forward to the TRAB for a vote.
Thank you. Any questions? All right. Topic Research Committee. And Dr. Harvey, were you able to give a... All right. Let me pull up my notes. Really, I don't believe there were any action items from that meeting. We had a... Let me pull those up. So we had a brief review on the upcoming DSHS rule revisions that were in progress. There are about 5 of them, which have all come through the TRAB for review and feedback, and we were given some dates for public comments, and then also the effective rules, expected dates that they would go into effect. We had a discussion briefly on review and development of TRAB position statements, and there currently were not any for under review, and there were no topics identified for sending forward to any of the other committees or to the full TRAB. Happy to answer any questions. All right. Program reports, Railroad Commission of Texas. All right. The reports were sent out electronically, so we have those sent out. Has everybody had a chance to review those, or anybody have any questions on Railroad Commission's rules, reports? All right. Oh, yes, Dr. Menner?
Are you going in order with A, B, C, or you just want the general?
I'm going through A, B, and C.
Okay, thank you.
All right. Next, Texas Commission on Environmental Quality.
I'm Ashley Forbes, TCEQ. We have the report before you. We don't have any significant updates beyond the report. I would like to bring to your attention, TCEQ hosts an environmental trade fair and conference. Each year, there is registration and fees associated with it. This year, on Wednesday, May 15th, we're having a full-day track for radioactive materials and nuclear. The scheduled speakers so far, we have our manager at TCEQ, Mr. Raines from the Compact Commission, Craig Wall from Uranium Energy Corporation to do the uranium industry update. Then Commissioner Janek would moderate a session of a panel discussion that has Commissioner Jimmy Glotfelty from the PUC to discuss the Texas Advanced Nuclear Reactor Working Group, followed by very brief remarks from Dow X Energy Project and Natural Resources, which is the Abilene Christian University molten salt reactor project. We also have Mr. Carlson from Waste Control Specialists and our own Lisa Brudigan from DSHS. So if anyone's interested, to check out TCEQ's webpage for more information. That's all I have right now. Thank you.
Thank you. And I'll just say I went to the Environmental Trade Fair last year. It was a very good conference. So if you do have the ability to go, I would recommend that. So any questions? All right. Thank you. Texas Department of State Health Services.
The report electronically. Did anyone have any questions? Yes, sir.
Yes, I had a question. If you turn to page 3.
Yes.
Under inspection data FY23 to date. I just believe it's a small typo there. If you go to X-ray remote and the fourth FY24 quarter 1, you have inspections 123, and then inspections with 33 violations. The number in parentheses, I don't believe that should be 60%.
Okay, we'll recalculate that and correct that.
Okay.
Thank you.
I also have a question. On the page 1, it has the second item is registration completed actions from September 23rd to November 2023. It's interesting that the new number of x-rays and lasers are a very large amount. And I'm just wondering, the x-rays of 830 new and 611 terminated, so that still makes over 200 new units in 2 months. And then the lasers are incredibly high. Is there a specific reason for that?
Texas is doing big business and is growing, so we are seeing an influx of applications for registration.
Are some of those the dermatology that we spoke about in the medical
committee? A very small amount.
A small amount? Okay.
Yes. But, lasers used for a lot of industrial sources. It's used for, other medical procedures, dermatology, as well as the skincare things and stuff like that. So there's a lot of different uses for a laser.
Is that typical for 2 months, or is just
So
unusually high?
we had some reorganization in our registration group over this last year, and the new leadership has simplified a few processes, and they are caught up. And so they have really had an increase in their workload because they've caught up on the backlog. So that should start to stabilize over the next coming months.
Okay, thank you.
Any other questions? Interesting to note, I think this was the first time in a while we haven't seen any Y90 medical events listed on here, so knock on wood. All right, next up, Texas Low-Level Radioactive Waste Disposal Compact Commission.
This is Stephen Raines, Executive Director of the Texas Low-Level Radioactive Waste Disposal Compact Commission. The only update we have is two things. Last summer we undertook a program related to the that's actually relative to the report you got from TCEQ. We've been monitoring the intake of out of compact volumes relative to the amount of capacity available, and took up a program to make sure there is not more incoming in than there is space available. We're hopeful we'll be able to put that program out of existence in a few weeks, assuming that gets approved and the new pad they're referring to it, section that WCS has built will get approved, and that will get rid of that program. We shouldn't have a problem with that, with almost doubling the capacity they have available for volume disposal. The second thing is that we have currently in Texas Register revisions to our management rule that are subject to public comment. We'd love to hear public comment from y'all if y'all have any questions about that. There are some minor adjustments to the management rule that the commission felt like they need to review. We've been working on that for about 3 years, but they are now in the register, and we're seeking public comment. I'd be happy to visit with y'all if you have any questions about that management rule revisions.
Thank you. Any questions? All right, thank you. Waste control specialists.
This is Dave Carlson, Voice Control Specialist. Real quickly, on Tuesday this week, we had our quarterly community engagement panel meeting at WCS. That's something we've been doing for a couple of years now. It's run by members of the community and has representatives on it that represent various industries in the community. TCEQ, including Commissioner Janeka, was there with us for that. They're part of the committee as well. And we discussed our recent Amendment 40 that just went through. We talked about the compact waste facility phase 2A that's now completed, and the documentation is in the hands of TCQ for review before we can actually use that next phase. We talked about our licenses and permits to give more clarity to the community on the particulars of that and the regulations that those things fall under. And there was certainly public interest in the meeting, specifically in the area of greater than Class C low-level radioactive waste, in the area of the Lanel True Waste that is still waiting to be removed from the facility in Texas, and also in terms of emergency response plans and more interest by the community in future discussions of that. Thank you.
Thank you. Any questions? All right. U.S. Nuclear Regulatory Commission, Bobby Janeka.
Hi, thank you so much. Just wanted to update the TRAB about a couple of meetings that the NRC is holding. Will be opportunities to engage if interested. Next Tuesday afternoon from 1 to 3 p.m. Texas time, the Nuclear Regulatory Commission is holding another public meeting, a second public meeting on the Part 61 and greater than Class C rules that staff are proceeding on. It has been years and years on that one, and there was one public meeting that the public engaged in. This is a second meeting opportunity. The Nuclear Regulatory Commission has highlighted they're providing in response to public interest and complaints. They've described this meeting as reserving a majority of the time for public presentations or questions and input. So I expect will attract a lot of the controversy in our field and in that regulatory area. That's next Tuesday, and it's explicitly virtual. The following meeting the next meeting I want to tell you all about is February 15th. That's down in Port Lavaca. The Nuclear Regulatory Commission will be coming down and answering questions, providing a more general overview of the regulatory path forward for the Dow X-Energy project at their Cedar site and what that process will look like going forward. There's no specific application before them with that attached to that project, as I understand it. So I think their questions to the public will be a little more general, but they're ready to engage with any public interest there. And I do want the TRAB to be aware of the previous day, February 14th, the morning of that day, we're going to have a government-to-government meeting with Nuclear Regulatory Commission staff answering questions to state agency staff from the state of Texas. I believe we'll be expecting to have some participation from state leadership offices as well, which I'm really excited about. I hope that the growing zeitgeist and interest in and around nuclear that Commissioner Glotfelty at the Texas PUC is helping shepherd forward. I hope that meets the always thoughtful and deliberate and very technically dense activities that the Nuclear Regulatory Commission is doing and working on, which impacts the same things, but just on very different processes, so the public engages and looks at it in different ways. So that'll be a really good opportunity to have the two governments speak directly. I don't think TRAB members would necessarily be able to step in and participate directly in that meeting because you may not be state employees and that may run crosswise, but I did want TRAB to be aware of it if there was any interesting questions or inquiries that y'all wanted to convey to those of us in the state agency staff world who will be engaged in that meeting. We'd love to pass that into the governor's office or to the nuclear NRC staff directly.
Thank you. Any questions? All right. Here's your report. All right, routine and continuing business. First up, recognition of TRAB members' excused absences. Excuse me, we've received a request for two excused absences. Dr. Masters and Ken Peters, both of them had work conflicts that they reached out to us, so we would entertain a motion to excuse those absences from this meeting.
So moved.
All right. Do you have a second?
Second.
All in favor of approving those excuses?
Aye.
Aye. Any opposed or abstaining? All right. Thank you all. Next up, update of DSHS rules.
Hi, thank you. Let me get to my notes. And I do need to make a correction from this morning. I had misread my dates on all these. So working with the radioactive material rule set, we have project 23R011. It deals with 7 different subsections. The proposed rule will be set up for public comment June 21st through July 22nd of this year. If everything goes on plan or goes on schedule, it will become effective in October 23rd of this year. The project to do with 289-252, which is licensing of RAM, project number 23R048. The proposed comment period for that this is the correction I needed to make. It's actually July 19th through August 19th. And that rule will become effective November of 2024, as long as it stays on schedule. The other rule projects deal with radiation machines. Project 23R012 is for lasers, which is in 289, Section 301. The public comment period for the proposed rule will be September 20th through October 21st. And again, if everything goes on schedule, the rule will become effective January 28th of 2025. The accelerator rule, which covers 289, 229, project 23R013, the public comment period for the proposed rule will be June 21st through July 22nd. and it will be effective October 23rd, 2024. And then the last rule, which really isn't so much with radioactive material use or machine use, it's the advisory board rule 289-130. The project number is 23R057, and that's in response to Senate Bill 1592, which added a TRAB member and made that member required to be licensed by Texas Veterinary Board. That draft will be set up for public comment July 3rd through July 12th, and then that will get revised, perhaps, depending on public comment, it might be revised, and the public comment period for the proposed rule will be December 27th through January 27th of 2025. And again, if everything goes on schedule, that rule will become effective April 28th, 2025. And that's the rule update.
Thank you. Any questions? All right. Thank you for the update. New business. Scrapyard incident, DSHS.
All right, so this one was not included in our quarterly report because it is still technically an open incident. We're still finishing up the last few things on it. But because this has made the news, we decided that we could go ahead and discuss a few things on it. So we were initially notified in mid-October by a Houston police officer that had identified a source on his radiation detector as he was driving down the road in Houston. And so they notified us. We went out and checked it out, and we were able to identify one cesium-137 source. And ultimately, we discovered 4 sources at this location. Turned out that these were devices that had been disassembled, but they were still sealed and intact sources, and they had been part of flow gauges for a chemical plant in their previous life. So it turns out that this example of finding these sources and having them safely removed was later used as an example during a Homeland Security Committee meeting that was held in mid-November at the national level. This, of course, prompted an article in USA Today the following week, just before Thanksgiving. So got a little bit of attention, and there was a subsequent article in the Chronicle and things of that nature. But ultimately, once we were notified that there was a source or that they had a detection reading, we sent investigators out and then worked with the facility itself. We were able to identify ultimately 4 sources that were at this location. We ended up bringing in the Region 4 RAP team, that's the Radiological Assessment Planning team that works for the Department of Energy. And they happened to be in town while this event was going on our side. And so they were aware and asked if they could join us and use it as a training event. And so it was a win-win for both sides. The scrapyard ended up bringing in an environmental decommissioning company to assist them on their side, and the sources were ultimately transferred to a secure location. Fortunately, we were able to identify the manufacturers of the sources, and then we did a trace back to determine where those had gone and who had owner in possession of them, and finally have tracked it down to the ultimate company that was responsible for the proper disposal of it. And we anticipate being able to close this violation or this incident with violations in the next few weeks. So it was while these sources should have never ended up at this scrapyard, it was a good example of somebody found it, they notified, and we worked the procedures and were able to handle this very safely and securely. And there was no one was harmed, no one was injured either at the scrapyard or in the collection of it or for the public.
Are fines or penalties being considered?
Yes, sir, if they're appropriate for the level of violation, and they should be. So, yes, sir.
Flow gauges.
Don't forget to use the microphone. Sorry.
Millicurie range.
Can you use the mic? I don't have that activity number on me, but they were significant that they picked it up, but they were at a point where they would not have been a general threat to, say, a member of the public or a worker of the scrapyard had been working in that area for an extended time. We did not calculate that would be of any personal threat to them from the exposure, so they were low level.
Doesn't the scrapyard monitor material coming in, and why didn't they detect it?
I can't answer that question. They've been there for some time, we believe, of several years. And the scrapyard had also changed hands recently before this incident occurred. And so there's a lot of unknowns in the gap. So But fortunately, people kept good records in the past history, and we were able to do the trace back.
What would be the normal disposal for something like a flow gauge that has?
So they need to go through the proper channels and be disposed of at the proper, resources. So whether that ends up at, one of the disposal sites or not, it depends on what the source is. But that's commonly what happens.
Thank you.
Excuse me. You said that the source was cesium 137. Then I heard you say sources.
It turned out there were 4 individual capsules that were located in this, and they were stored, or they were found in large containers with multiple other levels of scrap there, and so they were getting some shielding from the other scrap metal that was in those containers, and you couldn't have just walked by and looked in and said, oh look, there's something of concern there that has a radiation level. They were pretty much covered up, and to the general eye you would not have recognized them.
Thank you.
We did do some of that, yes, and the NNSA, the RAP team did some of that for us out of the Sandia National Lab.
Good questions. Any other questions? I guess my question would be, is there any kind of communication out to licensees that possess similar sources, just reminding them of the appropriate protocols for disposal of those kinds of sources?
Not anything specific other than, it's discussed on each inspection. They ask what they've got, what their plans are, their future plans for those sources, and if they're planning to retire any of them soon. When we have gauges that say malfunction, if they're able to fix the gauge, that's great, because they have a manufacturer come out. If they need to remove that gauge and replace it with another one, then, we have those conversations with them at that time.
Thank you.
So if that was in a large scrapyard, and how did it get discovered again?
So there was a police officer from Houston Police Department that was driving down the road and had his radiation detection meter on, and he had a ping, he had a ding that said, hey, there's radiation here. So he backed up and drove around again and figured out where it was and contacted us. So, and that happens fairly regularly. Our staff ride around with their meters on most of the time, and you'd be surprised what will ping. Most of it is perfectly licensed and legal. You just become aware of it.
All right. Any other questions? All right. Thank you. Next up, high energy lasers presentation.
So I'd like to introduce Dr. James Creel. He's a senior research engineer at the Bush Combat Development Complex at the Texas A&M University's Rellis campus. We were very interested in this project when they approached us to determine how it was that we would need to license and register this project. We don't have regulations on our books for this, so we worked with them, did a couple of site visits, and approved what they had, provided for us as their approach to the radiation safety aspect of maintaining the safety for the laser. Very interesting project, and we just really felt like the TRAB would enjoy hearing a presentation on this. So I will turn it over to you.
Thank you, Lisa, for the introduction, and thank you for the invitation, as well as the TRAB. Thank you for the invitation to come and speak here. I've brought a little show and tell. You can pass those around, and the members of the public too can have a look at those. So as she mentioned, my name is James Creel. I'm the lead research engineer for directed energy and diagnostics for hypersonics at the Bush Combat Development Complex, which is part of the Texas A&M University system and located on the Rellis campus. I'm going to talk to you today about our high energy laser, or HEL, test range that was established recently through the guidance and support of Raytheon and Department of State Health Services. I won't go into detailed specifics of the laser system. That is Raytheon's laser system. But I will give you some general information that I found just on the Raytheon website. I do know this information. Again, I just can't go into much detail about this. But how I'll start off in telling you is about who we are, who Bush Combat Development Complex is, how did we get here, why is there a need for a high energy laser range in Texas, and then where do we want to go? What do we want to improve in the range, and how do we want to move forward in the range in future testing and bring more capability into the state of Texas? Okay, next slide. So to start off, Bush Combat Development Complex was established in 2019 with the state support, the system support, and Army Futures Command, which is based here in Austin. We were graciously given, asked and given the name of former President George H.W. Bush. We're very proud to have that name on our organization. And from that, if you go into the next slide, from that you can read our mission and vision statement here. But the main goal of our organization is to get new technology into the hands of the warfighter faster than before. There has been a problem in the past in the DoD, and that is hard to get new technology into the soldiers' hands. And our ultimate goal in getting this new technology into their hands faster is to protect the warfighter, to bring our servicemen and women home safely and quickly as well. And so if you go to the next slide. So how did we get here? Why do we need a high energy laser range in Texas, and how did that come about? So as most people know, RTX or Raytheon is a company within or a part of RTX now in this umbrella that they brought a few companies together. Their high energy laser division is based in McKinney, Texas, just north of Dallas. And they build these 15 kilowatt laser systems for various DoD vendors or various DoD components. And these systems they build, in particular, I'll talk about the 15 kilowatt system. That's the one that was tested out at the Rellis campus. Their 15 kilowatt system is good for defending against Group 1 and Group 2 UAS or drones. And so we see what's going on in the Ukraine. We see what's going on in the Middle East, that the drones are being used to carry ordnance packages to target our soldiers, or target soldiers, target military vehicles, target aircraft, etc. And so there's a need to get these systems out to the warfighter, to military theater very, very quickly. These systems here, the 15 kilowatt system, it is an IR system. So we see in the visible light range 400 to 700 nanometers, blue to red, and sorry about that, blue to red. This is in the IR above 1,000 nanometers. This system has a certain range that it can operate at, and has a certain magazine depth based on the battery that it's carrying. These systems are relatively cheap to operate. You can think about if you target a drone or target something like that, it's a few dollars per shot to take down a drone, or say if it's a larger power or a larger power laser system, you can take out rockets, artilleries, mortars, and things like that. Again, at relatively cheap cost. As drones are becoming more and more prevalent, as they're becoming cheaper, as they're becoming easier to obtain, these systems need to be fielded in order to protect the base, in order to rapidly target and take down these types of drones or objects. And so with this, Raytheon has to tick lots of boxes whenever they're building one of these systems. And full-scale R&D testing is something that we cannot do here in Texas at this time outdoors. And so Raytheon has been doing all of their work around the country, and the closest location is in New Mexico, which is about 11 hours away. It's not a long path, but if you think about bringing vehicles over, bringing people over, and doing your testing, you're talking about at least a week or more to get things going out there. There's a full suite of testing, ability to go to stay below the backdrop of the mountains there in New Mexico. There's probably they can probably go above the horizon too with deconfliction of satellites and things like that. But there is a need, Raytheon identified a need for them to be able to come down and check the final few boxes off of their list before they delivered a system for example, the DoD. And so we thought, and they thought that the Rellis campus out in Bryan, Texas, an old Army airfield, would be a perfect place to do that. And so if you go to the next slide, please. So the Rellis campus, you can see the map, the Google map below. On the right-hand side is Bryan College Station. The Texas A&M Texas logo there is Kyle Field. You can see the airport down at the bottom right. That's College Station Airport. And then about 8 miles northwest of the airport is the Rellis campus. Now, going a little bit ahead to safety now, you'll notice that I put a star by the airport whenever people say lasers and aircraft. You kind of get wary. And so even though in all of the tests that we've done so far, we are firing below the horizon, we have a good relationship with the FAA. We know the people at the airport, and we issued a NOTAM for our test flight to notify all air traffic in the area that we were firing, even though we weren't going anywhere above the horizon. And so the Rellis campus, it is around 2,000 students and around 2,000 acres, and over $1 billion has been invested so far in it since 2016. It's a collaborative ecosystem built to foster advanced research, technology development, testing and evaluation, higher education, and hands-on career training. And there's an emphasis on national security there as well. And so if you go to the next slide. So I stand up here talking to you. You see one face. There are many, many faces that make up this team, and we definitely include DSHS in that because of their guidance and support of this moving forward. And you can see the laser system there. The 15 kilowatt pelletized laser system fits in the back of a flatbed F-350. These pelletized systems can be designed to fit in a F-250 long bed pickup truck for easy deployment to our soldiers and our allies. And so in the middle, you have Raytheon Technologies, Nick Maniscalco, Ronnie Curry, and David Raish, very helpful, and Hoppel and Bennett, and then our EHS on the Raytheon side, Nick Huser and Jason Redu. Now, the Texas A&M University system, everyone's familiar with Texas A&M University, but Texas A&M University system comprises of 8 universities, 11 state agencies, and it's quite large. If you didn't know that already, you'll notice that on this list there are a lot of people, and you'll notice even more so the parentheses below a lot of those. So one kind of thing that we have going for us, which is really great, is that we have a lot of former military members. And those military members bring experience of military operations and safety, and they also bring the knowledge of and the drive to protect our soldiers and our servicemen and women. What you'll also notice is that a lot of these are retired. So you know that they've at least got their 20 years in, and they understand how to not only do things safely, but also they understand how to work with the DoD. Furthermore, for the IPG, which is the Innovative Proving Ground, the people who led this test event for us at the BCDC, they are former test operations and they came from Fort Cavazos. And so we have our own people is the wrong word, but we have people that are familiar with how Texas operates, and we had those at the forefront of making this operation safe. And so this is the most important slide in this whole entire thing, because this is the team that it took to make it work. I think we ended up doing a good job, and I'll show you why. If you go to the next slide, please. So here's the RELIS range, an aerial view of the RELIS range. If you look on the far left, the blue outline is the campus boundary of RELIS. The red area is a proving ground fence line. So this is a restricted access airfield, Old Army Airfield. I think this is where Buzz Aldrin trained. And then the yellow is the laser reserved area for the test shot. And so the yellow area, even though the red area is cordoned off and controlled access, we further controlled in on the yellow area as well. If we go into the green circle there, this was the area that was cordoned off further. You can see the numbers 1 through 7 being different checkpoints or different barriers. At the top where you see above the number 1, just out of the page, is the Research and Integration Center, home to Bush Combat Development Complex. This is where we had our fusion wall, which you can see over on the right-hand side in the middle. This is where we did overwatch of the entire campaign. We coordinated everything. Even though the laser firing control was going to be, it was on site, on the runway itself. We have the high base for storage, and this fusion wall as well, where we pulled in feeds, we pulled in from the laser system, we pulled in range camera feeds and everything to understand what was going on through all aspects, was also able to be reconfigurable to a user's needs. If you go to the next slide, please. These were our entry and exit points, or ingress and egress points. So if you look around, you can see the controlled access gates, the warning signs on those. You can see different locations where barriers were placed. You can see areas that were overwatched, and you can see on the bottom right on the barrier plan that all barrier locations had that laser warning sign, excuse me, as a safety requirement. All of those checkpoints that were manned, people had, or the people out there were behind safety barriers, laser safety barriers, all had radios. There was a sweep pattern as we were getting ready to fire that swept out. Everyone that had visual line of sight, either overwatch or on site, had the ability to pause the test event in order if they saw anything that was out of the ordinary. All done by the range operations team. And I show like 3 or 4 slides up here where it talk about range operations. Our first day, whenever we started talking to Raytheon about the range operations, our range operations guys gave them a 30 or 40-page document that we needed to fill out with everything from if you need pens on tables to if who's bringing this laser safety goggles. Everything was very well done and well planned by our team. Next slide. So here's a kind of a cartoon imposed augmented image of the laser target, backstop, and culvert. So the laser backstop originally, you can see down by the truck with a laser on it. The target backdrop was originally 2 freight containers stacked on top of each other. These gave us an overall height of 24 feet and overall width of around 40 feet. This was, even though the laser spot is only a couple of inches wide or a few inches wide, our whole plan on this whole campaign for this first shot was to err on the side of caution. We decided to even go further and drop the laser target area into a culvert that already existed on the RELIS campus alongside the runway. This culvert had a 9-foot by 9-foot graphite backdrop. Graphite is very good at absorbing and dispersing the laser energy at that IR wavelength. And then in front of that, we went to Home Depot and bought a hardy board. Concrete is very good at absorbing the laser energy as well, giving a laser spot size, getting some characteristics about the laser system. It also burns up a little and turns into glass. Whenever you do that. And so you'll see an image of that later. On the right-hand side, you can see the distances that we used. It's a little bit, it changed a little bit from this, but we were at 1.1 kilometers for our longest shot, and then we did different shots at different distances, less than 1.1 kilometer, to bore sight in the system as you would with any weapon system that you have. Next slide, please. So here's our firing line. Because the runway gets hot, it's the same effect that you see the wavy lines over the roof of a car on a hot summer day, or the wavy lines over your home roof on a hot summer day. Those wavy lines can affect the laser, the energy deposited on the target. It's not going to steer the beam off the target to where it will go completely off the target, but what it will do is change the shape of the beam and do a little bit of change in the where the beam's landing. And so we wanted to avoid that. We were just trying to bore sight it in. That's actually that laser effectiveness is something we're studying on the research side at Texas A&M, whereas this is the testing and evaluation side. The cars there, they've been there for like 2 or 3 years. I think they're just figures now in there. But so no one was there, and you can see there's no one in sight because everyone was off that sight line. And this is one of the range overwatch cameras. All our range overwatch cameras also had IR and visible, so we could see if any hot bodies were coming in. Next slide. So this was something interesting that we had planned for. We're in kind of a rural area out on the Rellis campus. And so not only do we have wildlife, or not only do we have deer, but we have hogs as well. And so if you look, this is our fusion screen inside the command center, or the command center. And we saw down there on the range cameras, you see the 6 cameras there that I've kind of set over. We could see something coming in, and so we stopped the shot, and then we had a pause fire, and then we saw about 9 or 10 deer come in grazing along our shot line. This was right at dusk, but the thermal cameras picked it up, and it's we chased the deer off after that, but then they came back very quickly. So we decided to stop at that point, but it just shows you that what we had in place worked there. What you see on the left-hand side in those 4 images are the Raytheon's human-machine interface display. On the bottom left, you have a 360-degree pan view of what you're looking at, or where you're at with the laser system. And then you can put bounds on that. So you also see a elevation there from -20 to -20. With their laser system, they can write a line over there and say if the laser moves anywhere up above this line, you cannot turn the laser on whatsoever. On the circle with the different circles inside of it, that tells you the direction and the range that you're firing towards, and that's overlaid with a Google map. And then the top left, of course, is an IR camera, and then there's another IR camera up in the top there, and then a visible light over on the right that was just set down on downrange, to give us eyes on to see what was going on. And so if you go to the next slide. So lessons learned, and I think this is a video, so if you click on the image there, what went well? Safety, that first and foremost. There were no incidents. The range access and control, a few people tried to access the site while we were, not while we were live firing, but while we were getting ready to, but range control blocked them. These were construction crews. There's a lot of construction going on the Rellis campus. Wildlife appeared on site. Again, campaign shut down for the day. And the main thing here, which we were going for, was RTX was able to certify their laser system to hand off to the customer. We have some things we need to do on the range to make this more attractive for Raytheon and other customers in the future. And those are listed there. If you go on the next slide. So to kind of finish out here, I'll talk about kind of our overview of what we want to do at A&M for the system or with the system and for the state of Texas. Is we want to build a directed energy research, developing, testing, and evaluation ecosystem. We do directed energy research to look at the directed energy effectiveness of these systems. And that's done through the Aerospace Engineering and Bush Combat Development Complex near the airport at the Aerospace Laboratory for Lasers, Electromagnetics, and Optics, aptly named the Alamo in Texas. We have simulation and modeling that complements that, and we iterate with that. All our work with the Bush Combat Development Complex is agile work, so we meet the needs of the DoD as they change. On the right-hand side, something that we're commissioning now and that will be ready commissioning part of now for the directed energy side, and we'll be ready in the future, probably this summer. The whole thing will be ready, is the ballistic aero optics and materials range. It's a national asset scale enclosed range for directed energy and hypersonics research, development, testing, and evaluation. Essentially, this 2.4 meter diameter, 500 meter long facility out on the Rellis campus will be able to conduct hypersonic testing. It will also be able to do materials research, and my favorite is the directed energy side of that. This tube is fully enclosed. It can be brought down to vacuum to simulate propagation without the effects of weather. And then we can add weather effects into it. We can add fog, rain, dust, particulate, so forth and so on. We can simulate heating off the ground, and we can look at how these directed energy systems perform in different environments, characteristic of those encountered by our military around the world. And so we're very excited about that. Where we hope to go with the range, our goal isn't to compete with the rest of the U.S. Our goal is to complement the rest of the U.S. and what's out there. We would like to eventually go above the horizon with a target illumination laser. This is a 50-watt laser for target tracking, and then further on to a 15 kilowatt and higher above the horizon. Those are things that we will be hand in hand with DSHS as those needs arise and as we discover what we need. We have a lot of DoD partners. We know a lot of people who have these ranges already. We're not trying to reinvent the wheel, and safety is paramount for what we're trying to do. And so as we move forward, we'll keep everyone apprised. And if you go to the next slide, and yeah, so this is just an overview of the BAM facility as it's coming online. The system would like to invite the board members out whenever the facility is online after this summer. So that's an open invitation for you guys. So I think that's it for me. If you have any questions, please let me know, and I'm happy to answer what I can. Thank you.
Fantastic presentation. I was curious on several things. First, I'll start off with the beam spot size of the laser. What we're looking at in terms of the diameter?
It varies based on the optics that a customer is using, but a couple inches, a few inches, something like that, at the target.
And at the target, typically, what are the beam on times?
Sorry?
At the target, typically, what are the beam on times, or does that scale?
Oh, no, that's fine. Like, if you go back to the video, you can see like how much damage can occur for those on times. Like these drones that you see taken down can be anywhere from a couple seconds to like 5 or 6 seconds, depending on if you hit a control surface or something, very unique to or very needed for the flight. For the plate that you saw, that can take more, 10 seconds or so to go through. But yeah, it just all depends on what you're trying to take. This isn't. I don't want to give people the impression that this is like the movie Real Genius, where he just, where he just goes through everything like that. That's not what these systems are, and so, or at least this system that we're testing are. So yeah.
And maybe 2 quick questions. First one, do you envision incorporating any machine learning capabilities into this technology?
So that is, so that's an area of interest. It's an area that there's expertise at A&M. We haven't put it in our side of research and development, but I'm sure that companies that build these types of systems are, especially as the laser propagates through any kind of air, motion, or heat, or turbulence, or anything like this, you're going to have slight changes to the beam. And so if you can correct for that, you can get a more effective spot on target and less dwell time on these drones that you're trying to take down. So, yeah.
And lastly, for the atmospheric component, I'm just curious, are you endeavoring to look at the convective airflow issues?
Yeah, you mean like outdoors or?
Yes.
Yeah. So that can, the airflow doesn't, airflow in some sense helps a bit because you're not heating up the air around the laser. As the laser goes through the air, it'll heat up the air locally. And so if you stay in the same path, if you have a high power density, so watts per centimeter squared of area, then you can start heating the area, and that'll change your beam a little bit. So if you have an airflow, it's actually a good thing. It's just when you start having particulate or vehicle exhaust or something like that, you'll start losing your effectiveness of your directed energy system. Yeah.
Thank you.
Thank you.
Yeah, thanks for the presentation. Appreciate that. So is the technology for the laser outpacing that for exposure meters and other diagnostics that you'd have around it?
No, I think that the laser technology has jumped considerably in the last 10 years. I think it can follow the same Moore's Law trend that computers have over the last couple decades. But we are in a situation where fiber laser, which is what these lasers are based off of, fiber laser technology has taken the biggest leap. And so, so I don't think that they're going to outpace or they have outpaced the sensors, because the sensors have been always kind of better than the laser systems, at least in my experience. So whether that will be true in the next 15 years, I think so, but it remains to be seen. But we're happy with what we have in order to diagnose laser energies and things like that. It's just when you get to these, the only caveat I'd say is when you get to these high power lasers, it's you have to pick off some of this beam in order to measure it at target, and in order to pick this off without it burning your optic that you pick off this laser beam with, that's the biggest issue. So I'd say it's more about the optical coding technology and things like that, more so than the sensors.
Okay, yeah, thank you. So currently there is no limitation on the total energy of a shot, right? There are no limits presently.
In terms of at the campus or in general in building lasers, or
mainly for your facility right now, right?
So we had a special case our customer here, because they were based in Texas, had a laser registration already, and so they had an ability to use their laser at an alternate site, and so their documentation, I believe, was up to a 60 kilowatt system, whereas, so if another customer was to bring a laser system to us, then we would have to probably go through that paperwork again with the state to find that number. In terms of the range, as long as we're below the horizon, then the only thing that we may have to do is increase the thickness of the graphite backstop for the laser system in case we go through the board. But the whole purpose of this test was just to make a spot on the board, not go directly through it. In that case, yeah.
Sure, yeah. Last question for me then. Given the direction that you're heading for future facility operations, is there a need for the Department of State Health Services staff to increase their clearance?
Increase their what?
Their security clearances, because that would have to be done with some lead time.
Not necessarily, but it's something we can talk about if we need to get to. We need to go in that direction, but right now I don't see it needing to be there. Some of the people in our organization have a security clearance, but the majority, or I wouldn't say the majority, a large number don't. And these are, after all, private, or some of these are private customers. It's only when they're handed over to the military, I think, that clearance becomes an issue. Now, we are, I will say, we are a controlled access facility. So we vet through our research security office anyone who would come out on a site for that kind of thing there. So, yeah.
Points. So I have my Q clearance, and we have 2 other staff members that have recently received their Q clearance through the Department of Defense. And so should we have a need for that, we would, apply for and receive clearance from others.
So I don't know much about drones. So how high can they go? And can the range that you spoke about, what's the maximum range of the laser? And do you have video? Yeah. How do you target it? And how to stay on target? Like, do you miss?
Yeah. So I'm not a drone expert either. But these hobbyist drones, you can think about, I would think about flying a kite in terms of height, a long kite, I would think. And as far as distance, if you think about a hobbyist drone that you buy from Walmart or something like that, you're talking about maybe 10 minutes of runtime or 15 minutes of runtime. You don't have a lot of runtime because the batteries discharge. So you don't have that much capacity. So you can think about the range you can get to with a generic speed. But for more information about that, I would kind of look at maybe what's going on in Ukraine and seeing how close the drones are to what they're dropping. There may be some information on that. But again, I'm not the drone expert there. Your next question was the
maximum range. So it kind of ties in what you said. So if it's not very high, then you probably will get it. But do you miss? How do you stay on target?
Yeah. So the other thing is, staying on target. So there's two ways of tracking. One is passive tracking through optical, visual. You can see something moving. And that's locked onto, just like you probably see on the movies with the people in the planes and stuff like that, the lock on target. The other thing is the target illumination laser. This is a lower power laser, 50 watts or so that's in the IR that these systems use to illuminate the target such that it's easier to track. That's, again, somewhere we want to go in the future, somewhere we're not at yet, but that's kind of how it would go, and it all depends on the optics of what your system has about how far you can track them. But those numbers I don't have specifically. That would be characteristic of the system itself. but it can take a few seconds. It can take anywhere from a second to maybe 5 seconds for a smaller drone to take down a smaller drone.
Would there be mechanisms to block your targeting?
Not ones that aren't like at the fundamental research kind of on the back of a paper napkin kind of stage. The only other thing, like in the air before the drone can have, I'm sure you can put countermeasures on drones. The other thing is drone having a specific material might negate that. Depending on the laser wavelength, target material would have, or laser could reflect off the target or so forth and so on. So.
I have a question. So what is the setup of the combat complex? Is it a testing ground for private companies to use? Is it a research facility that you guys are marketing and you have customers that are interested in the technology? And then is it a program for kids on camp? Like, can you major in like upgraded lasers? Like, it's kind of, how does it fit within the broader ecosystem of your university?
So it kind of ticks all those boxes. We were stood up with a Army contract, Army Futures Command, $65 million over 5 years for 5 technology areas: directed energy, diagnostics for hypersonics, materials for extreme environments, networked autonomy, and resilient and real-time automated networks. We've added space and so forth and so on. We have professors who are the PIs. We have research engineers like me who are PIs and also just worker bees on the project. And then we also have students that are doing their master's, their undergraduate, their master's, their PhD, and do work part-time on this. Some of our research you can't publish in regular journals and things like that, so that's something we have to watch out for students to actually showcase themselves as they graduate. We've hosted interested DoD parties that want to use our mobility challenge course, a challenge course for vehicles and things like that, off-road testing. We've hosted small companies, those that participate in small business initiative research, SIBR companies. We've hosted researchers, just generic researchers from A&M campus, and yeah, it's something for everyone. We're not limiting ourselves in terms of the research we can do or the people that we can help. All in this effort to get newer technology into the hands of the warfighter faster than has been done in the past. If that answers your question.
Has this technology been implemented in the battlefield?
So, yes, it has. I think yes, it has. So it's been implemented in the battlefield. I'm not sure where. I don't have that information. But I've heard that, not only is this high energy laser weapon system, useful against drones, but when there's not a drone threat, it's good. They run it 24/7 for just surveillance. The optics, the ability to rotate 360 and then 180 off that is great for them when they're not engaging drones or the next evolution of drones swarms. So yeah, it's overseas. I'm not, again, no one's told me where, but it's there. Yeah.
Any other questions?
So the department was very impressed with the depth of experience and knowledge that their team has. Every question that we presented to them that we thought might be a problem, they had an answer for us, and they already had that answer. It was not anything that we were stumping them on. So they were very well prepared when they came to us and said, this is what we're proposing. How do we make this happen? And so we really have enjoyed working with them. The day we were there to do our second site visit, the laser arrived, and you could feel the excitement in the air. It was like Christmas Day because their project was finally coming to a point where they were going to get to put it into action. And so it was very exciting to be there.
And if you go to the team slide real quick, Sorry. Sorry, I didn't ask you if I could put this picture up, but I did anyway. If you'll notice that flatbed pickup truck has an AgriLife logo on it. So we really utilized everyone in the A&M system that we could. So they were probably happy that we saw the deer when we did. So, but yeah, I want to thank the board and Lisa again. And yeah, feel free to reach out. Lisa has my contact information. Follow up. So thank you. Sorry I took a long time.
Thank you very much. All right. Next item, we have identification of agenda items and topics for the next or future TRAB or TRAB committee meetings. The date for our next TRAB meeting is April 19th at this location. Does anybody have any ideas you'd like to bring up for topics?
So just a question for Lisa Bertigan. For the possible presentation on the cobalt magnet, is that something that's close, or what would you say?
Yes, sir. We talked briefly at the topic research that, we can present that at the April meeting. We did not want to double up and have this presentation today with the cobalt magnet one. And so we felt time-wise that, we wanted to go ahead and get you the high energy presentation. But yes, we're prepared to do that for April if that's what the TRAB would like.
Everybody agree? All right. Any other topics? All right. Hearing none then. Last item on the agenda is adjournment. Do we have a motion to adjourn? All right. Do I have a second? All right. Thank you. All in favor of adjourning? Say aye. Aye. All right. Thank you all.